In this question, we'll be using mathematical induction to prove the statement 11 to the n minus 4 to the n is always a multiple of 7. So we're going to take this, we're going to call this statement here, we'll call it p to the n, p sub n. So if n equals 1, we'll start with 1, which means 11 to the 1 minus 4 to the 1, which equals 7, which is, of course, a multiple of 7, 7 times 1. So if n equals 1, p sub 1 is true. Moving on to the second step, if p sub k is true, then 11 to the k minus 4 to the k will equal some 7 times some number. We'll call that number a. Show true for p sub k plus 1. So we have 11 to the k plus 1 minus 4 to the k plus 1. And our goal is to show that this is 7 times some other number, 7 times a prime. So let's get started. So what we're going to do is I'll split this 11 up. So I have 11 to the k times 11 minus 4 to the k plus 1. Now I can substitute 11 to the k. I like to call this my substitution step, substitution piece. That's 11 to the k equals 7a plus 4 to the k. And this can go in right there. So now I have 7a plus 4 to the k times 11 minus 4 to the k plus 1. Distribute the 11. We have 77a plus 11 times 4 to the k minus, I can break this piece up as well. I'll have 4 to the 1 times 4 to the k. Now, you can ask yourself, how many 4 to the k's do I have? I have 11 there and negative 4 there. So rewrite this as 77a plus 11 minus 4 is 7, 4 to the k's. And now I can factor out a 7. 11a plus 4 to the k, which you can see is 11 times some number, we call it a prime. So that was our goal. So now for the statement, thus 11 to the k plus 1 minus 4 to the k plus 1 is divisible by 7 if 11 to the k minus 4 to the k is divisible by 7. And hence p sub k plus 1 is true whenever p sub k and p sub 1 is true, and therefore the statement is correct or true by the principle of mathematical induction.